Hi everyone, I am Savaş Okay, a research assistant at Eskişehir Osman Gazi University since 2014. This video is the presentation of our recommended systems study at, let me read the conference name, the 4th International Symposium on Multidisciplinary Studies and Innovative Technologies Conference. This research is about significance weighting concept in collaborative filtering, in which the user similarity weights then may become more efficient to be part of in the prediction step. The presentation was prepared by me and presented by my workmate in October 2020, Sercan Aygün, who is also a research assistant at Yıldız Technical University. Moreover, this paper is also published in a journal as a selected paper publishing opportunity. If you want to read the article, you can visit the European Journal of Science and Technology journal website from November 13th. Enjoy!
Welcome to my presentation. I am Sercan Aygün from Yıldız Technical University. This work is done by my colleague from Eskişehir Osman Gazi University, Savaş Okay. Mainly, we work on the recommendation systems. Let's look first for the outline. I will just give first introductory information on recommendation systems. And then I will mention about the methodology, what is the standard approach and the proposed methods for the weight significance. I will mention on this. By giving the tests and results, I will conclude the presentation. So the recommendation system is a user and the item-based system. For instance, there can be some products that we buy, that we watch, and depending on these actions, we give some remarks, we give some likes and dislikes, and then the system recommends some items for us. It should be some social media dependent information like people that we know, or some suggested tweets. The watched movies, generally in the literature, is the movie recommendation is very famous. For instance, some remarks, some votes, likes and dislikes on IMDb. And depending on all these informations, all these user actions, remarks, the system gives some predictions, some recommendations for us. We can, in general, mention about the feature extraction, like the user-based or item-based. Because we will mention on an active user, we will predict the item value for this person. We will do some stuff on the user-based similarities. So similar users for a specific active user, we will find these similar users. Depending on the active user taste, we will recommend some items for this active person, and we will predict any unknown item. It should be a movie, for example. We will give a suggestion for this person. For the standard approach, we have a user item metrics. So the user gives some categorical or numerical remarks for items. And then depending on this active and all other users on the data set, we get some neighbors for the active user. So for the same wavelength, for the same taste. And depending on all this statistical information, we make a prediction. Actually, we have a 2D user item matrix in hand. From 1 to n, we have users, and from 1 to m, we have the items. And we will deal with this data in hand. This should be a data set. In the literature, for example, because we will be working on the movie recommendation system, the well-known one is the movie lens data set. There's Netflix also. So depending on any active user, we will be dealing with to predict an item value. This is a sparse matrix. There are some empty values, non-applied values, but any known values, we can make a test. We can try to predict it. For this, we deal with the active user. By obeying a constraint, it is this, that all other users for this test item I also voted, taking all these possible same wavelength neighbors, users, we will scan the data set for some feature extraction. This is the weights linear relationship, because we will be using the Pearson correlation method. We will get the weights from each user from 1 to n with the obeying constraint to the correlated for the item I. So we will get all these coefficients from each user, for active user, and we will store them. For choosing some neighbors from the same wavelength, we will sort them. For example, we will just process top n. So we will call it best n, top n weights to use in prediction equation. Up to now, it was with the like the linear correlation calculation, and then there will be the prediction calculation. So if you look at the equations, this is the simple Pearson correlation coefficient equation by considering the ratings like R and the statistical computation, we get the weights. And then by using these weights and rating values, we use the mean centering, or in other words, the weighted average of deviations from the neighbor's mean calculation to predict any item for the active user A. In between, so when we get the weights and when we are about to predict the item, there is the weight significance method. In other words, similarity weights are so crucial for us, and significance weighting is one of the techniques that manipulates directly the weights itself that affects the recommendation quality. It's actually can be thought of just the multiplication with a constant to update it. So we can say it's a mu, but it should be static or dynamic. So we have three approaches, alpha, beta, and CIC. Alpha is a static method. So it's a user-driven value at the beginning of all tests is decided, and throughout the test is applied. And then mu is decided depending on the red formula, and it's just updated for the W. And the other is the beta. Alpha is this time obtained depending on the dynamical approach. And there is the CIC, is a simple method. It's just the correlated atom count in between active user and the user. It's just like an enlargement of the W's by the mu multiplication. For the first method in red, in alpha, we throughout all AU pairs, all tests, we apply this static value because it's a static approach. For chart A, we have some W's as the obtained correlation in between active user and all other users. And in the second column, there is the user IDs and the correlated item counts. Depending on the user-driven 50 value for alpha, there are some greater and higher values. When we apply the weight significance, there are some changes for the W signified weights on the second chart. There are some decrements and the increments on the sorting. Because we use the user sorting during the selection of the neighbors, this is very crucial. We update the W's, and it directly affects the selection of the neighbors. This is one approach. There are some sorting changes, as you can see, ups and downs. The same chart can be applied for a dynamic method. This time, alpha is obtained depending on some parameterized beta fractions. And this is applied for each AI active user item pairs for each independent test, so it's dynamic. The same chart is again, this time alpha is obtained dynamically. After applying the weight significance, there are some decrements and increments on the sorting again after the application of the significance. And there is another sorting. So it's in a different sense applies and creates another sorting for the top n users. And there is the third and the simple method. This kind of an enlargement. This is a CIC, correlated item count method. The same chart from the real data set, by the way. We just multiply the correlated item counts exactly with the weight values, and we obtain the signified weights, as in B. And then we sort them. Again, the third different top N selection, different sorting occurs. So while we are doing the tests, we use two release of movie lens data set. One is the 100K, the other is the 1 million releases. So during the test also, I will just show independent results for comparison sense. For each user, we get 5 random test items. In each cell in user item matrix, there are some empty cells because it's a sparse matrix. So we choose the given remarks. But the test item selection is totally random. Not only, but also the random folds are the random item. We apply the k-fold cross validation, and the folds are randomly decided. So for the index matrix, after we apply, we obtain during the prediction process the standard approach without signifying the weights. So it's just immediately processing the weights in the prediction equation, and we get the predictions. Besides, for the comparative sense, we use a significance weighting method for 3 different approaches, alpha, beta, and CIC applied method, to compare them. During the tests, we applied a method for the neighborhood selection, like the top N decision. For this N parameter, we start from 5 to 100 for each 5 incremental steps. We make it parametric. Besides, for the random test item selection and fold randomization, we do this step each test attempt for 100 times to make the individual results averaging. If you look at the results for each data set release, 100K and 1 million, we start with the F1 measure. The bold line without signifying the weights method as the PCC alone. So in F1 measure for both releases, the green color line is the CIC method, the simple multiplication, what I mean the third method, is in the leading position, so it gives the best results. And for binary prediction accuracy, in 100K dataset release, PCC with signified weights by using the CIC method, again in the leading position. For error metrics, for the first release, what I mean 100K dataset release, the CIC method, just a simple multiplication method, is in the leading position for 1 million case. At this time, for the lower number of the neighborhood selection, it's getting better results. The same sense is obtained for the root mean square error also. For 100K, the simple CIC multiplication giving the best, but for 1 million data set, for the lower number of the neighborhood selection, it gives the better results. So all in all, in RS science, there are many different approaches to increase the accuracy. The one we today deal with is the weight significance method. So we obtained 3 different observations, and we underlined that the simple multiplication, simple enlargement, giving the better result. So for simplicity of the just multiplication method, different from some further computations for alpha and beta, CIC should be chosen during the tests. And for future work, we can apply the method for different data sets, like the music recommendation, for example. So the possible further application should be this. These are the references that we used during our construction of our paper. And thank you for your listening, and I'm waiting for your questions.